Okay, so today you're going to learn how to make your first ever cheat, and then this is going to be in a game called Soul Cube, and it's going to be written in C++. So things you need for this is going to be first off Visual Studio and some kind of C++ compiler, as well as a cheat engine to get your addresses from. Effectively, how this cheat works is it finds you need addresses to read and write to in your RAM where the game is held, and you're effectively just overwriting, in this case, your health variable. So obviously you're going to want to install a Soul Cube. I'll put the link to that in the description. And then also you're going to need a cheat engine. So how you're going to start is you need to find the address for your health. And to this, first you want to go up to this window in the top left here and attach a Soul Cube to cheat engine. Then you can see the health down here is at a value of 100. So if we search 100 into cheat engine and then scan, it will find all the addresses in your RAM which have the value of 100. So next what we need to do is to just get shot by an enemy, just to take some damage. Okay, perfect. So we've taken some damage. What we need to do is to scan for a second time, same with the value of 52, which is the new health value. And just like that, we get this address here is the value of our health. And we can check that by changing the value, just say 200. You can see down here that becomes 200. So we can label that as the health address. And how the addresses work in the RAM, how they are effectively stored, is using offsets. So how this works is there'll be an object which has the entity in it, and in the RAM just next to this object address, if you add an offset to that address, you'll get the health. So you can find that by right-clicking this and find out what accesses this address. And if you look here, you'll see there's a register, which is EBX or EDI, and then it adds the hexadecimal EC. So this means that the offset is EC, and that the entity object is EBX. So if you take this in EBX and add this address, call it the entity object. So effectively, you can also check this by going to memory view, tools, dissect data structures, put that in there, define new structures, and this way we can search through what's in the player entity. So this is going to have all the information of where the player is. So for example, if we look at 183.128.0.3, I can see there's all floats. So that's probably a position. If I move there, because it changes. If I jump, you can see that is the Z coordinate changing. And if we go to EC, we can see it's 22, which is the same as our health value. So once again, change that to 100, our health value gets changed to 100. So we know this is the player object, and that is the player's health with that offset. And how a Soul Cube works is actually as a static address to the entity object, or local. In this case, it's the local player object, and there's always a static pointer to this address, which is basically a static pointer. It's like when you close the game, it will always stay the same, and so that means that you can find the same address every time you restart the game. So how you find this is you take the address, which is the local player pointer, and you search for it as a hexadecimal number, because that's what it is. And when you scan for it, it will scan through all the RAM to find the correct addresses. And then if you look through this list, it's the ones written in green with ac_client.exe written in front of it. So take one of these, and this is your static address to the local player pointer. So basically, this will always be equal to the location of the player object, no matter how many times you restart your game. So this is a local player pointer. So we can get rid of this now. We don't need that anymore. Then we can take this, add an address manually, put it in, put it as a pointer, then say local player object, then okay, So this is permanently attached to our local player object. And then we can do the same for local player health, then add that offset that we found earlier, which was EC. And as you can see, this is, well, if we come alive again, this will be equal to 100. Sorry, a minor technical problem there. So I just had to get all the offsets again. So if we restart the game, open it again, and then reattach tree engine to the process. And now you can see all of these have come back again. It just takes a moment until you get hit for it to actually register and put these back to what they were before. So now we have all the values we need, we can start coding. So do you want to create a new project? And you want to find console app C++, next, and then assault queue tutorial, and create the project. So then it has all this stuff, you can just get rid of that. And first thing I want to do is go to header files and add existing item. No, not existing item. Add a new item. And you want this to be called includes.h. That's a header file, and you're gonna put all the things that need to be included. So this, first off, you want to add the windows.h header file. So this will include everything with the Windows API and all the functions and data types that you'll need, and also tl help32.h and iostream for any bits of data you'll want to print out. So that's all the includes, and then the first thing I'll do is include that in your regular C++ file. And then you want to go just make an int main function, which is like the first function that it will ever go to in C++ when your program starts. And so the first thing you're going to want to do is you're going to define some variables. So you want to define some unsigned integer pointers. Oh, actually, the first thing you want to do is quickly change this at the top to x86 and then release. That's just making sure it's the right data type. And actually, it's probably better if you do this as a dword, because it's specifically saying it's a 32-bit number. And in this case, it's first you want to define the process ID and the base module, which is like the module, it's like the base address of where the game is stored in the RAM. And then you're going to want to say PID is equal to get process ID AC underscore client. And obviously this function hasn't been defined yet. So we're going to want to create a new header file, and you're going to call this proc.h, and then a new source file called proc.cpp. So in here you're going to have functions which are going to return your process ID and your module base address. So you're going to begin in the header file, and you're going to want to include the includes file which I had before, and also Windows again, just due to some weird compiler problems you're going to have otherwise. And you're going to start by defining the getProcessID function, and as an argument you want to run a const char pointer, and you want that to be called process name. And that's just going to take the process name and then return the process ID of the function. And second, you want to make another dword, and this can be the get module base address. We want to put in the process ID and another const char pointer to the name of the module. And so that's the header file done. You're just going to copy and paste these and put them into the proc.ccp, which we're going to first off include proc.h. So you have these two functions, and now we're going to write them. These are quite complex functions. I'll explain what they do, but it's I'll put them in the description if anyone can't be bothered to actually write them themselves. So first thing I want to do is in the process ID, you're going to just define the process ID, which you're going to return as 0. And then you're going to create a handle called hsnap, and you want to say it's equal to create tool help 32 snapshots, and then as a parameter you're going to put in th32s underscore snap process, and then also 0 because we don't need to put in a process ID because we don't have one yet. And then you just want to check that the handle is not invalid, does not equal invalid underscore handle value. And if it doesn't, you're going to create a process entry 32 called proc entry. Then you're going to find the size, which is proc entry.dw size is equal to size of proc entry. And then you're going to want to say if the process 32 first, and then you're going to pass through the hsnap and the address of the proc entry variable. Then you want to say the process ID is equal to proc entry.th32 process, not parent process, th32 process ID. That's fine. And then you're going to break out of, oh, I forgot to include a do while loop. So here you want to do, and then just indent that while. And you want to do that while process 32 next hsnap at the address of the proc entry variable. And then you're just going to want to close the handle so it's not open indefinitely. Hsnap, and then return the proc ID. So effectively what this does is it creates a snapshot of all the processes that Windows currently has open. Then it in this loop here, it goes through all of them, checks if it's the one that you've put in as the process name, and returns the process that you're looking for. And that means that here in why is that undefined? Just capitalized. Get process ID. So that means that this function, which is in here, can now be referenced. Why is that? We've not included the proc.h file it includes. That should be fine now. Yeah, okay. So now we have the process ID. The next step is to get the base module. So we have to say base module is equal to get module base address. So you can put in the process ID and then the name of the exe again, which is ac underscore client.exe. So now we're going to have to define how we can get that base module, module base address, which is where this game is stored in the RAM. First thing we're going to do, head back to this proc.ccp file, and now we're going to start writing the code for this function. So first you want to begin by saying the dword mod base address is equal to 0, and it's very similar to what you did before. So you're going to get a handle, and then create to help 32 snapshots, and then th32cs underscore snap module. Oh, I need a bar line here. I include the bar line on my keyboards. My bad. So have that there, and then th32cs underscore snap module 32. So this is just using both 64 and 32-bit versions, and then because this time we can put in the process ID because we already have it. So that will create the handle to the process, and then we just go and check if it's invalid again. If the handle is valid, then create a module entry 32. I call that mod entry. We can define the size as mod entry dw size is equal to the size of mod entry. And then we've got to say if the module 32 first hsnap, and then put in the address of mod entry. If that's true, then you're going to want to do, and then you want to do it while module 32 next hsnap and the address of mod entry. And in this statement, you want to do hold up. I've just spotted an error with the last function we wrote. So if we need to include if not wcsi cmp the proc entry dot exe file and then proc name. If those are true, then we can do that. Get the process ID. Sorry, that was an error from before. And then I want to do something very similar here. If not wcsicmp mod entry dot sc module, then module name, then you want to say the mod base address is equal to casted dword mod entry dot module base address. Then you want to break, and then here close the handle of hsnap and return mod base address. So that should be our function for getting module base addresses and process IDs completely finished. And we can test these now. So if we do std cout, std hex, pid, std nline, that's just printing it out. And do the same for the base module. So what that function actually does is very similar to this one, is it cycles through all the processes again. But this time, because we have the process ID, we can use the process ID to identify which one it is and then return the module base address. That's what that does. And now we can run this. And 23DC is the, actually that's not supposed to be in hexadecimal. So if we quickly get rid of that line, because the process ID is just an integer. Yeah, so it's 9180, and then the base address is 400,000. So now that we have the process ID and the base address, we can get to changing some of the variables. So first, what we're going to want to do is create a handle called handle. We want to say that's equal to open process, and this is basically opening a handle to the process, and you want to define it as process all access. So basically what this means is it gives you access to a handle which can be used to read and write the memory of the process. We don't need to inherit, so we just pass null through that and then just put in the process header that we got through from before. So all that will do is just allow us to read and write to the process. So the first thing, the next thing we want to do is define another D word here and just define it as the local player pointer, and then also define an integer health, set that equal to 9999, for example. That's the health that we're going to change it to. So first we have to retrieve the local player pointer, and the way we do that is by using the Windows read process memory function. First we've got to put in the handle to the process, then you're going to want to cast this to, like it says here, an LPC void. And then here you're going to put your, you're going to have a look back to cheat engine, find your local player pointer, and you see it's AC client. So this AC client bit, that's the module base address, and that's the offset. So for this AC client bit, we're going to want to put in base module, and you're going to add this offset. So you say plus OX to make it hex, and then add that. And so that will mean they'll be able to read the pointer of the local player. And then you want to tell it to return that to the address of local player pointer at the size of local player pointer. And then we don't need to specify the byte spread, so we can just pass a null pointer through that there. So that means that we'll have the local player pointer, and we can just check that. CR std hex local player pointer std underline, and so this should return the same value we have here, so it's 05954110. 05945140. So it's the same value there and there. So that means we have our local player pointer. So now we can get to the fun bit, which is overwriting. Well, we can say while true. So that means it will run forever. And you can say write process memory. Put in the handle again. This time not to an LPC void, but to an LP void when you cast it. And in the other brackets, you want to put the local player pointer. And then add the that's defining this. So this is the local player pointer from before, which is the 07B214F8, and then you're going to add EC. Is that correct? I think so. Add that. Wait, that's the wrong number. OX EC, and then at the address of the buffer. Wait, no. Yeah, we need to define the address of the health. So that's the value it's going to take from it and overwrite it as the size of health, and then we just can pass a null pointer again because you don't need to specify them bytes. This should now work. It's not running. See, there we go. Now my health is at 9999 and it doesn't go down. So, yeah, that's the first ever cheat you've written in C++. So what you've done is you've reversed the address yourself using cheat engine, and then learn how to use C++ to overwrite them.